All right, so this lesson is on completing the square. And completing the square is the third technique that we're going to look at for solving quadratics. We've already talked about solving using factoring and solving using square roots, and this is going to be a third option, and we'll talk a little bit later about why we might want that option. But in the meantime, I want to start out with some factoring problems. Now, I'll spare you actually factoring these, but I've got three of these here, and they all have something in common. The first one, x squared plus 8x plus 16, that factors into x plus 4 times x plus 4. And I'll leave you to verify that on your own if you're not convinced. But notice that they're both x plus 4s. It's x plus 4 times x plus 4. So another way to write that, a little more compact way, would be x plus 4 quantity squared. And if you were to factor number 2, you would find that it would factor into x minus 3 times x minus 3, right? Again, same thing here and here. And again, you can check that on your own, but another way to write that would be x minus 3 quantity squared. And maybe you see the pattern at this point. This last one will factor into x, erase that, x plus 5 and x plus 5, or x plus 5 quantity squared. And not every trinomial has this pattern. Not every trinomial factors this way, but some do. And the ones that do are called perfect square trinomials. They're trinomials that when you factor them, you end up with two terms that are exactly the same. In this case, x plus 5 and x plus 5. Now, the name of these isn't important. The important part is that there is a commonness between them, that these perfect square trinomials exist. Now, our objective is going to be to create perfect square trinomials, and you won't know why we're doing that yet, but the first type of problem you might see in your assignment would say something like, find C to complete the square. Find C to complete the square. And so maybe you get something like this. X squared minus 4x and then plus C. So what I have here is I have part of a trinomial. You know, I have the x squared part and the minus 4x, but this part's missing. And I want to choose this number so that I get a trinomial that's one of these perfect squares. Now, in order to find that, I might have to see if there's some sort of a pattern, some sort of a connection with the numbers. Like looking up here at the 8 and 16, and the 6 and the 9 and the 10 and the 25. What is it about those numbers that makes it a perfect square? And the answer to that is a really simple pattern. The completing the square value, we'll call it C, is really the middle term divided by 2 and then squared. And let me verify to you that that is the case. So if I take 8 and I cut it in half, that's a 4. And 4 squared is 16. Negative 6, if I cut it in half, that's negative 3. And if I square it, I get 9. 10, if I cut it in half, I get 5. And 5 squared is 25. That's the connection. When that is true, I have a perfect square trinomial. So down here, if I take negative 4 and I cut it in half, I get negative 2. And if I square a negative 2, I get 4. And 4, that is the number that I would need to have there if I was going to have one of these perfect square things. So you cut the middle term in half and square it, and that's how you can create a perfect square trinomial. But then, of course, the question is, well, why in the heck would I want to create a perfect square trinomial? How can that process help me? So that leads us to the next kind of problem that we're going to do, which are solving problems. So the directions are going to be solve by completing the square. which I will probably abbreviate if I have to write it again. So for problem number 2, we're going to solve this equation. X squared plus 4x plus, by plus I mean minus 4x minus 2 equals 0. Now, this is a quadratic, and we've already got two tools in our box to solve this. We could try to factor it, see if it would factor into something, to see if it equals 0. But I'm going to tell you right now, this is something that doesn't factor. You can try all the combinations you want, but you will never get anything with this -2 that gives you a middle term of 4. This is just a wash. This is not going to work at all. The other strategy we've learned is square roots, and so with square roots, I got to get the square by itself, and maybe I could do that. X squared equals, and I'd have to move these to the other side, -4x minus 2, and we know when we get the square by itself, we square root, and x equals, and I'm not sure how to take the square root of x. I have a problem. I have a variable left in there, and so that might not be a very good strategy either. So I've got to figure something else out, some other way to be able to solve this. And so factoring is great when it works. Square rooting is great when it works, but what do I do when it doesn't? And completing the square is another option. And so here's how it works. The first thing I'm going to do is I'm going to add 2 to both sides of this. I'm going to add 2 to both sides of this. And when I do that, this will be the result. And notice I purposefully left myself some room over there. And this step I call creating a gap. Not official math terminology, but I end up creating a gap right here. Okay, and I've done the same thing to both sides of the equation, adding 2. So I have not changed the equation. So I want you to understand that. I've just done a little manipulation on it. So my second step is I'm going to find C to complete the square. So I said I was going to abbreviate that. I'm going to find C to complete the square. And what I mean by that is I simply want to know, what could I put here to actually make that perfect square trinomial? And I know that I have to take the middle term and cut it in half and square it. So that's 2 squared or 4. So that is what I need to complete the square. So my next move is going to be to add that new term to both sides. So I have x squared plus 4x, and now I'm going to fill my gap with plus 4. So that's what I came up with in the last step. So I found C to complete the square. So this guy right here, this is a perfect square trinomial. Now, the one thing I have to be extremely careful of is that on the other side, right, I have a 2, but I can't just add something to one side of an equation, or else I've changed the equation. So when I add it to the left side, I have to add it to the right side as well. So my move here is I'm adding C to emphasis here on both sides. So, and again, just to show you visually, I'm taking that number and adding it to both sides. And again, I have not really changed the equation. I have not changed it because I'm doing the same thing to both sides. So let's take quick stock of where we are here. I've got x squared plus 4x plus 4 on one side, and on the other side I've got a couple of like terms I can combine. I've got a 6. So keep in mind here, I have not changed the equation. I've just manipulated it to meet my needs. Now, the cool part about this is now I have a perfect square trinomial. I know how this guy right here will factor. I know how it'll factor. It'll factor into x plus 2 and x plus 2. How did I know it was a 2? Well, it's the half of the middle term. 2 times 2 gets me the 4, but you can actually, if you want a little secret, back up here, this number right here, that's going to be what your factoring number is. But I'm not even going to write it like this. I'm going to write it as x plus 2 squared equals 6. But I can't emphasize this enough. I created this trinomial. I manipulated it. I added 4 to both sides. I created that gap just so it would factor like this. Just so I would get this relationship, because you know what? So let me write this down here. So this was the factor. And it's an easy factoring. You shouldn't have to think too hard about it because it's that perfect square trinomial. And it's always going to factor using that pattern. And now at this point, we're going to solve what we've got using square roots. And really, at this point, this problem that you're left with here could have been one that we did in your last quiz, right? This could have been number 7 on your last quiz. I could have asked you to solve this. So at this point, I'm going to square root both sides, and I know that square and square root cancel. So x plus 2 equals plus or minus the square root of 6. X is almost by itself. I have to minus 2 from both sides, and in the end, x will equal negative 2 plus or minus the square root of 6. And I couldn't have gotten there with factoring. I couldn't have gotten there, at least at first, by taking the square root. I had to set up a situation where I could take that square root by completing the square. So this is the end of the concept. I'm going to do one more example. So if you feel like you're good and you've got it, you can stop now. But for those of you who are interested, I'm going to do one more example here. All right, quick pause in the action here, and here's the next one we're going to do. Now, what you might want to try to do is maybe try this one on your own, and then and pause the video while you do that, and then come back and see if you got it right. But either way, totally up to you. The first thing I'm going to do here, if I'm going to solve with completing the square, is I'm going to create a gap. So I'm going to minus 3 from both sides. So I have x squared plus 8x gap equals negative 3. And I need to fill that gap. I need to figure out, what could I put there to complete that square, to have a perfect square trinomial. So that's my c value, and I'm going to take the middle term and divide by 2 and square it. So 8 divided by 2 is 4, and 4 squared is 16. 16 is the magic ticket. If I have a 16 at that spot, then guess what? I am going to have completed the square. So I'm going to take my 16, and I'm going to add it to both sides. Now again, it's important that you add it to both. You can't just change one side of an equation, or else you have changed that equation. So then we have x squared plus 8x plus 16 equals 13 if I combine the like terms. So it's like I have a brand new problem. I haven't changed the values of the equation. I've just manipulated it in such a way to make my life a little bit easier. Now at this point, this guy's going to factor. Now it's going to factor, and remember, I'm creating that perfect square trinomial, so I know it's going to factor into x plus 4 squared. How did I know it was 4? Well, it's really half of the middle term, or you can think of it as the square root of the last term, or you can take it from right here. It doesn't matter. But x plus 4 times x plus 4 is the ticket, however you want to think of that, but you shouldn't have to work too hard at it. I guess you could make a t-chart if you want, but if it's always going to follow that pattern, you can probably, after practicing a couple, go right after it. Equals 13. Okay. So at this point, I've got a square all by itself, and I can leverage a square root. So I'm going to square root the left side, and I'm going to square root the right side. And so I'm left with x plus 4 equals plus or minus the square root of 13. X is almost by itself now. I just have to go minus 4, and x equals negative 4 plus or minus the square root of 13. Now, probably when you saw the first example, you're like, wow, these take forever. Well, of course, with explanation, I want to go slow for understanding purposes, but you can see once you get these down, you can roll these things out in like 30 seconds to a minute. So that's it. That's completing the square. If you have questions, we'll answer them in class, but hopefully this helps you as far as maybe either understanding it if you didn't in class, or seeing the lesson if you were absent. So, yeah.